Alright class, we're going to go ahead and start a new section, and actually I am going to combine section 1.6 and 1.7 because they kind of go hand in hand. Before I do that, I want to go over a couple of housekeeping rules. First one, my desk is completely off limits, so no one is allowed to be at my desk except for the substitute. Number two, no one leaves at all. That means you should have taken care of your bathroom situations before the bell. So no one leaves unless you're called with the pass. Secondly, no food and or drinks at all. Whenever I am not there, y'all tend to be messy, so nobody should be eating food or drinks. I know second period likes to leave food on the floor, so they are definitely not allowed to eat. Third period, we have students like Essence that leaves wrappers on the floor, so let's go ahead and avoid that situation. And let's go ahead and get all the other classes to not eat or drink in the class. Next is stop this video as needed. So if I'm going too fast and you need to go back and rewind it or catch something or slow down and stop it, that's fine. And also, there will be a quiz on Friday. So make sure that you're studying for that. It will be over parent functions, and I will review briefly today, and tomorrow when I'm back in class, I will review with you. I would like to go ahead and move the homework. Instead of it being due on Friday, I want it to be due on Monday. So that's another housekeeping item that I wanted to discuss. Homework will be due on Monday. Obviously, there will be no tutorials today because I will not make it back in time. If Miss Mimi needs any help, she has the subfolder which is located on my desk. It's orange and it's entitled subfolder. In there are instructions, and it has a list of students whom I have selected in order to help her and assist her with the class. Alright, so let's go ahead and continue. I want to go ahead and start with section 1.6. And the first part of it will be a review, things that you should have known already. It says, write a linear function for which f of 1 is equal to 3 and f of 4 is equal to 0. Now keep in mind, this time I am not giving you a set of points in the regular coordinate form. I'm actually giving it to you as a function style. In other words, input versus output. However, you should make the connection that it means the exact same thing. For example, you are used to seeing inside the parentheses what letter? Letter X, exactly. However, now that X has been replaced with a certain number. In this situation, it's been replaced with 1. In this situation, it's been replaced with 4. The output will always be your Y value. So in this case, the output of this function will be 3, and the output of this one will be 0. So the question is, find the slope. Well, actually not find the slope, but write a linear function. In other words, write an equation that is linear. So the first thing that you need to do is find the slope. And the formula for slope is y2 minus y1 over x2 minus x1. So the way that I labeled this is 0 is my y2, which is placed here, minus y1, which is 3. Secondly, over x2, which happened to be 4, minus x1, which happened to be 1. 0 minus 3 is negative 3. 4 minus 1 is 3, and negative 3 over a positive 3 is a negative 1. Now remember, you were just tested on this. Once you get your slope, you're going to select either of the points and use either method that you choose is best or easiest for you. I've done y equals mx plus b. That works. This time, I feel like using point slope form because we haven't used it in a while. So that formula is y minus y1 equals m times x minus x1. So then what you have to do after that is basically substitute. Y And you can choose whichever set of points you want. It works the same way. I'm going to use this one right here. So y minus 3 equals m, which is your slope, and we decided, or we evaluated that our slope was -1, parentheses x minus x1, which in this case happened to be 1. Okay, so let's analyze what we're going to do here. We are going to distribute this -1 to the inside of the parentheses. So we get y minus 3 equals -x plus 1, because a negative times a negative is a positive. Now we have to move this -3 to the other side, so we have the plus 1 here, and we're adding a 3 to it, which gives us a plus 4, and then we have a -1x, or simply -x. So our linear function is going to be f of x is equal to -x plus 4. You kind of have to start getting in the habit of realizing that when you see the word function, you want to have it in f of x notation. When you see the word equation, most likely you have it in the form y equals -x plus 4. So make sure that you know the difference between those two different types of situation. Okay, this is the cubic, square root, and reciprocal functions. We're going to talk about those for a little bit. And the first one that we're going to talk about is the cubic function. And for those of you all that don't know yet, the cubic function looks exactly like this. And I think we've determined that the domain and the range is all reals. The function is odd. I believe I did an example of this one that it was odd. Remember, the definition of an odd function is that when you substitute a negative x into the function right here and you get the opposite, then it is an odd function. Also, we discussed that all odd functions have symmetry about the origin. So here is the next characteristic that we discussed about it, and that it was symmetric about the origin. All right. We also, I think we've written down before that the graph goes through 0, 0, which is also the origin. I believe this is something new right here, increasing. And it's increasing from -infinity to +infinity. Again, take your finger if you have to, and you always want to read from left to right. So in this case, if you read from left to right, you are increasing all the way up until you get to 0. But then when you get to 0 and you continue, you are still increasing. So therefore, when you have situations like these, it's best to say that you're just increasing throughout the whole graph, which would be -infinity to +infinity. Okay. Again, you've seen these 6 common functions before. The first one being the constant function. Basically, it's a horizontal line with 0 slope that goes through the y-axis. Next, we have the parent function that is called linear. And with this one, the equation is y equals x. We know that it has a slope of 1. We know that it has a 0 y-intercept. In other words, it crosses through the origin. We also know that it's a positive / increasing function. And speaking of function, we know that it's a function because if we were to place a vertical line anywhere on this line, it would only cross once by the vertical line test. Okay, the next function we've discussed is actually the absolute value function. Again, it is a function because if you place a vertical line anywhere on this picture, you would only cross it once. Some neat things about this one is that it intersects, well, not intersects, but they meet at the origin right here, which is 0, 0. This line actually has a negative slope. In other words, it's decreasing. And then from this point on up, it's actually increasing, and it has a positive slope. In regards to domain and range, our domain would be all real numbers, and our range would be y is greater than or equal to 0. Next, we discussed a radical function, which is y equals square root of x. We said that it originated from the origin. We also said that our domain had to be greater than or equal to 0, and our range is also greater than or equal to 0. Is it a function? I believe it is, because if you were to place a vertical line anywhere, it would only cross once. Going back to the absolute value, realize that it has symmetry about which axis? It has symmetry about the y-axis, that's right. And what do we know about functions that have symmetry about the y-axis? They are considered to be even functions. So make sure you remember that. Look at this line. It has symmetry about the origin, because if you take this piece, it's symmetrical with this piece, which is about the origin. Okay, let's look at the next parent function, and that is the quadratic. We know a lot of things about quadratic. It's y equals x squared as the formula. It's a parabola shape. It has a vertex, and another word for a vertex for a parabola that's opening up is a minimum. So a vertex slash minimum at the origin. This part right here is decreasing, so it's decreasing from negative infinity to 0, and then it's increasing from 0 to positive infinity. It has symmetry about the y-axis, so that means it's an even function. And it's opening upwards. So I believe that's it. It is a function, because if you were to place a vertical line anywhere, it would only cross one time. Next one, of course, is the cubic one, and I'm not going to go over much into that because we've already discussed it in the previous slide. So make sure that you remember a bunch of these characteristics of all of these common functions. Okay, a new one that we're going to be discussing is the graph of the reciprocal function. And actually, reciprocal, I believe, is a very simple term. I want to use more of a mathematical term, and you should be able to tell me what kind of function this is. Can anybody tell me? It's a rational function. Remember, we discussed rational functions? One thing that you should remember about rational functions is what kind of graphs they produce. They produce these, what I call elbow looking type graphs, which are called hyperbolas. And in regards to hyperbolas, there is always going to be a vertical asymptote and a horizontal asymptote. Basically, these are boundaries. In other words, this curve can go as close or get as close as it can to either of the asymptotes, but they will never touch. Same thing here. Okay, so this is y equals 1 over x as the reciprocal function, or in other words, a rational function. And the next one we've discussed before, it's called the greatest integer function, and it's also known as the step function. I really would just be pleased if I showed you a picture like this. You would be able to say, oh, that's a step function or a greatest integer function. Again, we'll discuss more about these when we cover limits towards the end of the school year. Okay, so that is a brief review of parent functions. Now we're basically going to continue and move on with the next section. If this video stops, because I don't know, I think I get 15 minutes every time I make a video, but if it stops, just get somebody to come up to the computer and go on to the next video. Okay, so let's continue. Now we are going to discuss section 1.7, which involves shifting points, it involves transformations of functions. So let's go look at example 1. You've seen this example before. I believe I started off this semester with this kind of question. And let's go ahead and basically plot these points. Be careful, because look at each hash mark. I'm going by 2's. So in this case, let's look at this first one. This would be 2, and then it would be 3. So this is 2, 3. This one right here is going to be -1, 2. And this one down here is going to be 1, -4. Okay, so make sure you plot those